So, hello everyone. Uh, Nice to meet you here on a breakfast seminar. And my name is Volodymyr Tkach. I am a senior lecturer of Black and Gate Technical Institute. And our today's topic is an anomalous user behavior detection and prediction. This topic is a part of a breakfast seminar uh, series within the PROMIS project, which is a professional master in information security. And let's go. So, first of all, let me introduce you an agenda for today's breakfast seminar. We'll talk a few words about preemptive security through secure engineering. And then actually I will explain the main theses of this topic of anomalous user behavior detection and prediction. And then I will give a brief introduction to the PROMIS general information and our courses and how to apply. So let's go. Today you will go to the deep dark forest. We will build a safe place there and set up a fence with metal cans on it to make some noise when someone is trying to interrupt the perimeter or get over the fence. And then we will face the enemy, which is actually anomaly and anomalous user far before it comes. So here we are. We are at the entrance of a deep dark forest, and let's go. Well, the forest is actually a metaphoric understanding of the digital world uh, around of us. So it definitely hides threats, and you know that. But in fact, this is where you are dealing in. This forest gives an air for your business, and this is actually what you are doing. And there is no other forest, so we have to handle this, and we have to deal with it, and we have to understand what kind of threats and uh, abilities it brings. And the main fact is that uh, the vision boundary uh, is very short and narrow, and we can see only something that is very close to our company, very close to our uh, projects or software, anything. So this is why we have to at least uh, understand what exactly surrounds us, what kind of data flow comes around. And according to Harvard Business Review, we are not using pretty much the uh, data that surrounds us in decision making. So less than half of structured data is actually used only in decision making. And over the 99% of unstructured data is not actually being analyzed or used at all. So we are losing possibilities. We are losing the ways to investigate the data that comes and that surrounds us. And on the slide, you can see that the volume of information, the volume of data, excuse me, that surrounds us is going up in an exponential way. It's overwhelming. And you see it's split into sensor and devices data flow, the social media, voice data, and corporate data, which are almost equal. The voice data is for now not the equal part of the whole flow. And the volume, as you can see, is an exabyte. Is terrifying. So among all these scaries, among all these digital threats, we are going to build up a safe place, like it's pictured on the slide. And this is actually your safe place. You think it is safe. And why? Because you think you know it well, and you might probably know it well. You can manage processes inside of this safe place. This is actually your business, and this is why it is safe. But it can easily become unsafe because even on this picture, in this metaphoric understanding of your safe place, you can see a lot of ways to get inside of your safe place. You can use stairway, you can use like something like a tire, and well, anything. You can just use the plane to get inside from the air. And this is how we can metaphorically get inside of your safe place. And this is how it looks like in real life. This is your probably safe place. You know that it has a very um, very large infrastructure. It contains a lot of devices, a lot of systems that are involved in a security process. Or maybe you don't have one, but still you have a lot of you have a quite big infrastructure. And this is your perimeter of safety, perimeter of security. Um, and this is how it looks like in real. But in fact, how do we protect the place to become more safe? Um, well, it's obvious in terms in definitions um, of our safe place metaphoric one. We have to put a fence. Yes, here it is, and then we'll have to put the door, which will allow good users to pass and disallow bad users uh, not to pass. Disallow bad users to pass too. So how do we understand which user is good, which user is not good, which is bad? They can pretend. Users can sometimes pretend and seem to be a very good one, but they have a slightly different behavior. And now we have to understand what exactly behavior is and how do we measure it if we actually can. So behavior is basically a quantitative and qualitative user data to understand how users can interact with a system of like any kind. And this actually means that we are analyzing the data, but in fact, to bring more usefulness from data, we have to extract the information out of it. We have to get an information which is useful. And well, let's say how to extract data, how to extract information out of data. Let's take a look on web-based system logs, access log. It contains, well, normally contains information, kind of source IP address, destination IP address, the user agent, which is more complex information, it contains browser information, operational system, device, etc. And refer, which is a string, request, size of data in bytes, time, request frequency, and so on. So as you can see, some of them are parts of a log string. They are just exactly an information domain, because it's not a data, it's just concretely source IP. This is concretely information where this request come from, and destination IP as well. But some of those features, we call them features, they have to be calculated. So they are not just raw data. They are data that has to be calculated. So let's say, well, about request. Request is just a string. It's a string, and we have to extract data. How many characters in it? So we will get a length. We can extract a specific page or specific, some sub path or subfolder inside of this request, or we can get any other information, the type of request, which is a get, post, or something else, etc. So this information can be extracted out of the string values, but more important than this information can be calculated. So let's say the size of data in bytes is probably, well, it's a raw data, so we can actually get it from the string. But request frequency is well, is calculated field, and it has to be calculated in order to understand what the behavior is. So how user behaves. Well, let's say some user just might have an access to a website and go to a login page, let's say. And this just once, and then he logged in, he was authenticated, authorized, and then, you know, do whatever it's supposed to do. But for some users, this cannot be that easy. Some users can perform requests one by one every single, you know, minute, let's say, or every 5 seconds, every hour, whatever. So in this case, we still can see the log string. This is just a log string. We cannot see user himself. And this behavior, so this frequency is kind of very abnormal. It's anomalous, right? So this is why we have to uh, measure calculated results in order to understand what actually user behavior is. And talking about behavior, we have to understand what is actually normal versus abnormal. And well, eating hamburger is probably normal, and eating paper is not. I don't eat paper pretty much, so I hope you do not too. Um, Dancing is good. I don't dance, but still, it's a good, it's normal way of how people spend their time. And squeaking is, well, it can happen, but it definitely is not normal. And playing chess is a good hobby, and it is probably normal instead of digging. Digging is not normal. It's not probably a regular way spending your time. But all this is quite good when you are a dancing hamburger eating chess player. In this case, the left column is completely normal for you, and the right column is, well, kind of strange, uh, so can be treated as abnormal. But what to do if you are a pretty hamster? In this way, everything goes vice versa, and the eating paper, squeaking, and digging is exactly what you are do for living. This is what you are supposed to do. And eating hamburger, dancing, and playing chess is not normal. So we have to understand that any anomaly, any abnormal situation depends on the context. So we have to bring the context to any understanding of what is normal, what is not normal. So now we have to understand what anomaly is. Let's go to the definition of anomaly. The British dictionary says that anomaly is a deviation from the normal or usual order, type, etc. And we will try to a little bit correct this definition. We will add the definition that anomaly is a deviation from the normal or expected order, type, or behavior, which is in our case is more relevant, or irregularity of any kind. So this is what we say about the anomalies. And anomaly detection is applicable in different domains, and one of them is probably, you know, maybe very you are familiar with this, is a fraud detection in credit card transaction banks. When you go to, let's say, you come to Ukraine, and here you are going to whether withdraw money, or you want to make a payment online, or you want to make a payment in a supermarket or in a restaurant, and for some reason bank declines your transaction and says, well, we'll try to detect whether it's fraud or not. And well, it's pretty common, and it is also being used in a different domains. So what does it actually look like in um, in a mathematical way? You can now see in the picture the anomaly data points, which are only 5 of them uh, on the chart. And here's the main cluster of what is actually normal. And why is it normal? Why is it normal? Because it's it lays in the very specific area, and it doesn't cross the border. And 5 red points, they belong to an anomaly data set, because they are quite far from the main cluster, from the normal behavior, from the normal way of dot is supposed to have. But in the terms of math, it's probably very easy to understand what exactly is normal when you're looking at the picture with those red dots. Let's play the game. In this case, I offer you to choose which square is a normal, as well, is not normal, okay, in the definitions that we have. Can you point to anomaly? Yes, it's definitely a second square. So the second square is quite big, right? So the rest of them have the same color, has no outline, has, well, the same size, except second. But okay, that's much easier to define an anomaly if you have such quite a simple example. But what if in this case, I would ask you to point again to anomaly. Which is anomaly? Which is which? Yes, and nope, it's not 4. Nope, not 5. Not 3. And not second. No, not really. The actual answer is 1. Why? Why? Because it has the most similarity to any other. Because the fifth is has its specific difference of size. It's of different size. The 4 has different color, and the rest is the same. It has an outline. It is a square. The third again has a very specific like outlines, very specific um, difference. It's not square, it's a round, right? It's a circle. And the second has a very specific difference. It has no outline. And again, the first has an outline. It's square, which is the most. It's right, which is the most. Well, it is probably as the most of the rest. So this is why you can see that anomaly is not necessarily something that is quite different. It can be anomalous, the same. And this is what is difficult to understand by just a human mind without analyzing, just on hop. So this is why this kind of information you will not be able to process. You will not be able to figure out which string is exactly anomalous in this case. So we will talk about the machine learning a little bit further, but from this perspective, we have to extract as much information from any type of data that we have. So again, data and information. So we have to extract the information out of the data. And here we extracted the features that can be then used in the machine learning algorithms to predict or detect something that we want. In our case, it's an anomalous user behavior. So features are event name, log source, event count, start time. Well, there's a specific low-level category, which is always the same, whatever. So source IP, destination, username, query string, and refer. These are the main features that we can use. Of course, after some kind of processing them, we can use them to obtain detections and predictions. So, talking about our fence that we have to build around, we have to mention that there's plenty of um, different tools and methods and approaches that are somehow related to defense. So among them, we can find a firewall, an IDS or IPS system, which are respectively intrusion detection system or intrusion prevention system, or endpoint protection, like DLP, antivirus, anti-malware, or so. So here is also definition of defense in depth, which is an approach to cybersecurity, uh, which say that the defensive mechanisms are layered in order to protect valuable data and information from a perimeter on the very far end down to a data on the very middle, where it has to be safe through the network, host, and application. So now we have to put an alert cans to our fans uh, in order to protect it from violators, from someone who is gonna get over the fence, and they will make some noise, and we will figure out that someone is trying to get over the fence, and we actually have to monitor every person, or not actually a person. It can be also other device or something else. We have to monitor it's coming through the door in and out, and also we can have an alert, time to time from someone that someone is trying to get over the fence. And nowadays, those cans are not iron; those cans are not steel. They have a name of CM, which is Security Information and Event Management, which has an ability using the forwarders to put those forwarders on the perimeter of security perimeter of your company, let's say, and then send the information from the perimeter, from the foreposts to the monitoring to operational center. And well, here you can see four of them that are probably one of among one of the um, most powerful and most common, most famous. I prefer, just my opinion, I prefer using Splunk because of its architecture, its model. You can install a lot of different other applications to use them within the Splunk um, main engine. So what does it look like in real? I will briefly show you how to actually get the anomalies detected. Uh, Here you can see this is an actual information from the company that I work with, but I'm not allowed to disclose the name or the data type because of an NDA. So here we can see that we can try to find an anomalies in different ways. Like it can be a face portrait, like request to size, and using the spectral clusterization and the machine learning toolkit, which is to the right top corner. Its logo is, like I said, you can use different tools, and machine learning toolkit is actually a third-party tool that can be installed and can be used within the Splunk main engine. So here we can see not only something that is quite big, but also we define as an anomaly something that is quite small. So basically, we define the kernel, we define the core cluster of the data, and then something that is outlying, it's an anomaly in our definition. And it can be obtained by using this script. Again, it's not specific, but I swear this has been used to get this type of information. And also, there's a way to use a time series, not only face portraits with different variables, but also using a time series allows to get the information, like in real time, and using the forwarders allow to to accomplish, to complete this information in it every single second. Well, we have ability um, to tune this time, right? We can we can get information every single second, every 5 seconds, every minute, every hour, whatever, or we can get different types of information from our forwarders. And on this chart, you can also see that here is the timeline from 10, what is it, 45 to 12 o'clock. And here you can see here's 700,000 events happened during this only 1 hour and 15 minutes. So this is kind of very heavy traffic that we are investigating and looking for anomalies. So this is just a simple example of how anomaly can be detected. And to obtain such chart, we use this script, which is actually, I'm sorry, I didn't mention it. This is the SPL. It's a Splunk language that is quite similar to script languages, and also it uses some specific parameters as the SQL does, structured query languages. So it's quite very flexible, and you can use it to obtain whatever you have to. So here is how we can predict. Now we are talking only about the detection of an anomaly, and how do we predict? Just in a simple way, using the same Splunk and the machine learning toolkit, and using the input data, we can predict the behavior of system, subsystem, or some particular specific user. And then we can predict that this value should be higher than normal. So this is going to be anomaly or not. And in these definitions, anomaly can be also that when user is expected to get the high value of whatever it is, but instead user gives a lower value. And in this case, it also can be threatened as an anomaly. So this is pretty much it for the second part, for the anomalous user behavior detection and prediction. I hope you did enjoy it. And now we will talk about the PROMIS project, Professional Master in Information Security. This presentation will be available on our official website, and the PROMIS edu.se. You will be able to download this presentation and take a more detailed look onto the information that I'm going to tell you. And we have, for now, so far we have 3 courses that are in the process of development right now. So first of them is mostly an introductory course to security in software. Well, the course responsible is Dr. Tony Gorshik, and having this course and applying for this course, you will understand how to understand what preemptive security is, and how to plan your development product from the perspective of security. Because a lot of companies, a lot of products are being developed in a manner of they just deliver product, and then they're asking for security, and they have to they require to secure the project, to secure the product. And preemptive security is the way to plan of development of products and services. And also you will be able to understand what is actual risk assessment and how to take ROI into account. And you will be also able to develop and use secure architectures, because this is what we start with. We first have to define an architecture, right? And then you will have the ability to compare and weigh the benefits and costs of non-functional aspects in combination to security. So this is basically about how security issues imply what is an impact of security issues to functional and non-functional aspects of software development. So this is basically an overview of what security in software is. The second course is Software Security is DV 2595, a course responsible Dr. Dragas Ili. And this course is more deep dive into what exactly software security is. You will be able to detect risky programming practices, and you will know how attackers exploit risky programming practices. So if you want to know more about how exactly security, software security works, you will have to apply to this course, and uh, you will be enjoyed. And the third one is a web system security, which is DV 2596, course responsible Anders Carlson. And as far as the most common uh, way of delivering your product for nowadays is web-based systems. So as far as we are on the web, almost completely on the web, we have to understand what kind of threats brings the web to our product or our system, to our customers, etc. And learning this course, applying this course, you will be able to find a lot of information on the whole process of how web application works and how this can be secured, how can this be insecure, how this can be violated, and so you will get an acquaintance to an OWASP methodology, and you will be you will know much more about how web system security works, how web systems work actually. And well, how to apply for course, the entry requirements. Um, you have to be a professional. You have to have a professional experience within an area related to software intensive product. So you don't necessarily need to be security specialist, not really. So to apply for course, you have to create an account of user at antagening.se or universityadmission.se. Then second, you have to search for PROMIS courses by the name and send in your application. Then you have to upload your required documents, employer certificate, and then reply to any offer of admissions. So you can also contact Anna Eriksson, via her email anna.eriksson@bts.se, and visit and bookmark it, promisedu.se, for more information about our courses, ongoing future courses, because we'll go to the next stage. We'll build up, around 15 to 20 new courses. This will be next year. So for now, for this year, we have three main courses, which I had an honor to present to you. So this is basically it for today's seminar. Enjoy your day, and I am ready to answer all your questions if you have one. Thank you.